Morning people, just a note I want to add something I forgot to mention in my last lesson. As you can see there, I worked through that section in detail. The first part of the question is to calculate the position of centroid. What I didn't mention was, I sort of mentioned bits of it at the end of it, but I should have said this as well. We have a channel, we have an eye section, we have a plate there, and you can see there from this compound section here, that there is the y axis, as I said, and as I mentioned in that lesson, that this compound section is symmetrical about the y axis. Okay, what does it mean? Now I worked at y top, y bottom, but I didn't work at x left and x right. And because there's symmetry about the y axis, there is x left and x right is equal to each other. Okay, so what we do is we take the full width of the section, which is actually the distance from there to there, which is, that's right, it's the 260. Okay, so x, in this particular case, x left is equal to x right. It is equal to the full width of the section over 2, and it is 130 millimeters. Okay, and of course y top and y bottom we worked out like I showed you already. Okay, now people, I forgot to mention this bit over here. Okay, now working at x left, x right, that's all there is to it. Did you hear that? Why I'm spelling that out is because finding x left and x right is simply a one-line calculation, and I will give you not more than 2 marks for that over there. Now what some students do, they don't pay attention to that there, and then they work it out. They take moments like we normally do. That's not wrong, but you don't need to do that. Okay, then they work about this point and they take moments about it, and they do a long calculation. They waste a lot of time, and then they get to the end there, then they get x left and x right is equal to wrong answers. So they wasted their time and they did all that work for 2 marks that they only should have gotten. Okay, so when there's symmetry about an axis, for example the y axis, x left is equal to x right is equal to the full width of the section, which is 260 divided by 2, 130, and that's it. This is, you do the long proper calculation. Okay, right, let's take another one. I'm going to the core notes. Okay, on page I'm going to page 4.15 in the core notes, which is on Blackboard there. I'm going to the one at the top, for example, on page 4.14. Take this one for example. Okay, have a look at it, think about it. There we've got 2 channels back to back with a space between there, 2 plates over there. So has this thing got any symmetry? Yes, it has. About which axis? It's about both axes. So let me just do this quickly here. Let me get this right. Let me try this. Right, there's my y axis and there's my x axis. So that's x and that's y. And people here in this one, we don't need to do this long calculation like that. Okay, why? Because there's symmetry about both axes. So when you work this out, all you just say x left, it's not going to work so nicely because of is equal to x right is equal to the full width of the section, which is 320 over 2. So I'm going to just do it quickly. So x left is equal to x right is actually equal to 320 over 2, which is actually equal to 160 millimeters, and that's it. Okay, and y top here is equal to this is equal to y bottom. And can you work it out? How far is it from the bottom of the bottom plate to the top of the top plate? It's the height of the channel, which is 240, and there's 2 plates there, so that's 12 plus 12. So if I take 240 and I say plus 24, because there's 2 12mm plates, plus 24 is equal to divided by 2. So y top is equal to y bottom is actually equal to 100 and Anyway, you know what I mean. This doesn't want to work so nicely because of this PDF thing. Sorry about that. Okay. Anyway, it's 240 plus 12 plus 12 plus 24. Okay, you divide by 2 and it should give you 100. Man, should give you 132 millimeters. Okay, so people, that's it for that section when you work out the position of the centroid. And the position of the centroid is where those two axes meet each other. Okay, so if you see something like this, don't do the long bar, X bar, Y, and all that stuff. It's gonna be, it won't be wrong, but you don't need to do it, and you could make a mistake and get it wrong. Okay, right, people. So now this particular one had symmetry about the y axis. This particular one had symmetry about both axes, and some of them will have symmetry about the x axis only. So let's look for a section here. So if I look for this one here, okay, this particular section has got symmetry about the x axis. So y top is equal to y bottom, and so on and so on. Okay, right. So that's all I want to say for this particular short lesson, people. And I'm going to go and work at another example on steel compensation. Okay, I'll see you in the next video.